Hello everyone, welcome back. Today we are starting a brand new chapter, differential equation. Now many students think this chapter is difficult because they see the derivatives and get scared. But let me tell you something. This is actually one of the easiest chapter in class 12 mathematics if you understand the concept properly. In today's lecture we will cover what is the differential equation, order of the differential equation, degree of the differential equation, solution of the differential equation, and different type of first order differential equation and their solution technique. Finally, let's discuss a previous year JEE Mains questions. So let's get started. Before we define a differential equation, let us understand why we need it. Suppose a particle x is moving under the action of external force. Suppose in this space a particle x is moving under the action of this external force f of x. So according to the Newton law of motion, the force acting on a particle x is equal to the mass m multiplied by the acceleration. So the mathematically we can write in this way. Say mass into acceleration, that is x double dot acceleration, is equal to external force f, that is f of xt, and t belongs to real number. Such a relation between a function x and its derivative is called the differential equation. Notice that this equation contains the second derivative of the position function. Any equation involve this derivative is called the differential equation. So in this type, mx dot is equal to f of xt. We got this equation. So this type of equation is called the differential equation. Before I give you textbook definition, let me ask you a simple question. What is derivative? The derivative tells us a rate of change. Now, whenever an equation contains a derivative, we call it the differential equation. Let's write the formal definition. The definition is an equation involves the derivatives of one or more dependent variable with respect to one or more independent variable is called the differential equation. Suppose dy dx is equal to x square. This is one of the example of differential equation. Here y is dependent variable, x is independent variable. So this example is the one of the differential equation. So this type of equation is called the differential equation. So the formal definition is an equation involves the derivatives one or more dependent variables with respect to one or more independent variable is called the differential equation. The differential equation is two kinds. One is the ordinary differential equation, another is partial differential equation. In our chapter, we are only focused on the ordinary differential equation. This type where the ordinary derivative are involved, that is dy dx, d2y dx. This type of derivative are involved is called the ordinary differential equation. When the derivative are partial, that is del y, del x, this type of derivative are involved, we called it the partial differential equation. So forget everything, we only focus on the ordinary derivatives, dy dx, d2y dx2, this type of. So suppose an equation like that, dy dx is equal to sine y. This is the ordinary differential equation. So we only focus this type of equations. And your syllabus only focus the ordinary differential equation. Now next thing is where do the differential equation actually appear? The answer is almost everywhere. They are used to study the motion of the projectile, rocket, satellite or the planet. They are used to electrical engineering to analyze the current and the voltage in a circuit. They describe the heat conducting in the solid like the rod or a slab. They also help us the model of the chemical reaction, population growth, biological system, financial model, and even the spread of the disease. So the differential equation are not just a mathematical topic, they are the language used to describe the many real world phenomena. So next move to the new topic is the order of the differential equation. Student, this is one of the favorite topic in the board exam. So formal definition is that order of the differential equation is defined as a order of the highest order derivative of the dependent variable with respect to independent variable involved in the given differential equation. So whenever asked the order, don't panic. Just ask yourself one question. What is the highest derivative present in this differential equation? That's the order. Let's solve a few examples. Suppose example 1. Suppose take this example dy dx plus x square y is equal to 0. So ask question yourself, what is the highest derivative present in this equation? That is dy dx, the derivative. So dy dx is the highest derivative. So highest derivative is 1 dollar derivative. So order is this, equation is 1. So see the example 2, that is d2y dx2 plus x sin y is equal to 0. Can you tell me what is the highest derivative? Is the derivative are involved here? So d2y dx2 highest derivative is 2. So order is 2. Similarly, this example, the highest derivative is involved here. Here also the derivative involved, but highest derivative involved here. So highest derivative is 4. So order of this differential equation is 4. So that is very simple. So we see only the highest derivative of the differential equation. Here highest derivative is 1, here highest derivative is 2, here highest derivative is 4. So order of this differential equation is 1, this differential equation is 2, this differential equation is 4. So when we find the order of the differential equation, first look at the highest derivative of the differential equation. Ignore everything else, ignore the coefficients, ignore the power, just find the highest derivative. When you see the highest derivative, that is the order. So highest derivative tells you the order of the differential equation. So that is the order of the differential equation. So move to the next concept. The next concept is degree of the differential equation. So suppose the differential equation, suppose dy dx plus x square y is equal to 0. We see that order of the differential equation is 1. Next we find the degree of the differential equation. Suppose as a formal definition, many students confuse order and degree of this differential equation. If you understand the simple trick today, you will never make that mistake again. So if you look the definition of the degree, the rules are clear. To determine the degree of the differential equation, it must first be express a polynomial equation of its derivative, that is y dash, y double dash. Y dash means dy dx, y double dash means d2y dx2, y triple dash means third order derivative. Actually this is a simple form we use in these differential equations. So the degree of the differential equation, it must be first expressed as a polynomial equation is derivative, that is y dash, y double dash, y triple dash, etc. Once in this form, the degree is defined as the highest power of highest order derivative involved in these equations. If you find the polynomial expression of this differential equation, then check the degree is defined the highest power of the highest order derivative involved in this equation. Suppose in this equation is highest derivative is dy dx. Next we check the power of this derivative. So power is 1. So this equation is dy dx plus x square y is equal to 0. So highest derivative is dy dx first order, and next we check the highest power, that is 1. So this degree is 1 and order is 1. Now let's look at some example to understand the degree. Now tell me one thing, can the degree always be defined? I will answer this question later. We observe the equation 1, that is the example 1 is a polynomial equation in y triple dash, that is y triple dash, that is y double dash, that is y dash. So that is the polynomial equation of y triple dash, y double dash and y dash. That is the definition we previously see the polynomial equation in the derivative. First work is we express the differential equation in the polynomial form, that is y dash, y double dash, y triple dash, etc. So this is the polynomial equation in y triple dash, y double dash and y dash. And this example 2 we see this is the polynomial equation of y dash, that is y dash square plus y dash minus sin square y is equal to 0. Not in the polynomial in y, because sin y is not a polynomial. So we only need the polynomial of derivatives, not y. So that is enough to find the degree of the differential equation. So the degree of such differential equation, that is the equation 1 and equation 2, can be defined, but the equation 3 is not the polynomial equation in y dash, because if you see this part, sine of dy dx is not a polynomial equation of the derivative. Thus differential equation cannot be defined the degree of this differential equation. So Previously I asked you one question, can the degree always be defined? Answer is no. That is the one example, that is dy dx plus sin dy dx is equal to 0, because sine of dy dx is not expressed in this form of polynomial form of the derivatives. Y dash y double dash cannot be expressed in the polynomial form. So that reason this differential equation degree is not defined. So the degree of the differential equation when it is the polynomial equation in the derivative, we means the highest power of the highest degree involved in this given differential equation. So here the degree must be positive index. That is the differential equation, highest derivative involved here. Highest power is 1. So degree of this differential equation is 1. Here the highest derivative is dy dx, that is order 1, and the highest power is 2, that is 2. So degree is 2. But this differential equation degree cannot be defined. So in the view of this above definition, one may observe that differential equation 1 is degree is 1, differential equation 2 is degree is 2, while the degree of the differential equation 3 is not defined, degree is not defined. So in this case you only remember these two things. First, we express differential equation in the polynomial form of the derivatives. Second thing, we check the highest derivative and this power, that is the degree of the differential equation. If this equation cannot be expressed in this polynomial form, so that type of differential equation cannot be defined the degree of the differential equation. So that type of differential only define the order but cannot define the degree. So the degree always not defined. Next, move to the solution of the differential equation. The formal definition is a function y is equal to f of x is called the solution of the differential equation. It is sufficiently differentiable. Why sufficiently differentiable? Because suppose the differential equation, that is d2 dx2 plus xy is equal to 0. So we only need the two derivatives, y dash and y double dash. So that means the sufficiently differentiable, and when they substitute it into the differential equation, reduced to an identity for every x in some interval. Now this thing we understand properly when we solve some example. Now we know that the definition of the solution of the differential equation, but a question arises: how do we actually check whether a given function is a solution or not? Let's understand this with a simple example. The example is d2y dx2 plus y is equal to 0. Remember one point, a function is not called a solution just because someone says so. It must be satisfy the differential equation. That means after substituting the function into the differential equation, left hand side and the right hand side must be equal. Now look at the example. Suppose this is the example, d2y dx2 plus y is equal to 0. Suppose I claim that y is equal to fx is equal to a sin x plus b is a solution. Should we believe it immediately? No. In mathematics we always verify. So find the derivatives. So given that y is equal to a sin x plus b, so we find the derivatives, that is y dash, that is a cos x plus b. We need second derivative, that is y double dash is equal to minus a sin x plus b. Now we put left hand side is d2y dx2 plus y. So d2y dx2, that is second derivative, that is minus a sin x plus b, and y is a sin x plus b, a sin x plus b. So that is equal to 0. Thus we get 0. So left hand side which is equal to the right hand side, it is equal to 0. So therefore y is equal to fx, this function y is equal to fx. So y is equal to fx, that is y is equal to fx, that is actually a sin x plus b is a solution of this differential equation because it satisfied the differential equation. When some function is satisfied the differential equation, then we called it the solution of the differential equation in certain interval. So if we observe this function y is equal to a sin x plus b, so two arbitrary constant are involved, that is a and that is b. So this type of solution we called it general solution because it involves the arbitrary constant. Now my question, how many constants are involved. So it is depend on the order of the differential equation. So that is second order differential equation. So it's exactly two arbitrary constants are involved. So that is here A and that is B. If we put particular value of A and B, then this general solution becomes a particular solution. If we set A is equal to 2, B is equal to pi by 4. So then the solution y is equal to, suppose this function f1, f function reduced to f1x, that is 2 sine x plus pi by 4. So if we find the derivatives of this function y dash and y double dash and put this equation, then we see that left hand side and right hand side must be equal. So this is also a solution, this function 2 sine x plus pi by 4. So this type of function we called it the particular solution. So solution are two types. One is general solution, and second is particular solution. Now comes our fast solving techniques. First order first degree differential equation. This is the general form of the first order first degree differential equation. That is dy dx is equal to f of x comma y. If we write the differential equation in this form, then we called it first order first degree differential equation, because here involved the first order and degree is 1 because the power is 1. So we call it first order first degree differential equation. Now let's look at some example to understand the first order first degree differential equations. Look the first example, y into dy dx is equal to x square plus cot of x. Here the first order, because the derivative is dy dx, so first order, and degree is 1, so the power is 1, so that is first order first degree. So this is the one example of first order first degree differential equation. So another example is, suppose dy dx is equal to x minus y over x plus y. So this is the another example of first order first degree. Previously we discussed the general form is dy dx is equal to f of x comma y. So the first equation we can make it in this form, dy dx when we divide by y. So that is x square plus cot of x over y. So we convert to in this form. And the second equation, it already in this form, dy dx is equal to x minus y over x plus y. So the equation 2 also the first order first degree differential equation. I think you understand the first order first degree differential equation. Any differential equation in this form, then we called it is first order first degree differential equation. Look at the another example. The third example is, suppose x dy dx minus y is equal to x square cot of x, or x belongs to 0 to pi. This is the another example of first order first degree differential equation. Look, the last example is sec x dy dx minus 2y is equal to 2 plus 3 sin x, when x belongs to minus pi by 2 to pi by 2. This is also the first order first degree differential equation. We can easily convert these two equations in this form, dy dx is equal to f of x comma y. When we divide here in this equation, we divide x by the whole terms, then we get this form. And also in the fourth equation, when we divide the sec x divided by the whole equation, easily get this form, dy dx is equal to f of x comma y. Now let's move to the first method for the solving the first order first degree differential equation, the method of the separation of variable. If the differential equation is of the form, suppose our given differential equation we can write in this form, dy dx is equal to f of x comma y, that is the first order first degree differential equation. If the right hand side we can write as a g of x multiplied by h of y, then we apply the method of separable of variable. As the name suggests, this method works by the separating all the terms involving x onto the one side of the equation and all the terms involving y onto the other side. That means here first we write this differential equation in this form, dy dx is equal to, right hand side we can write in this form, g of x into h of y. Then we separate x terms and y terms individually. Then we take y terms here, that is dy, h of y is equal to g of x multiply d of x. Once the variables are separated, we integrate both sides to obtain the solution. Then we integrate both sides. Then we get the solutions. However, remember that this method can only be used when the differential equation can be written in the form, this form, dy dx is equal to g of x into h of y. If the equation cannot be expressed in this form, then we must be used the another method. Let's understand this technique with an example. Look this example. Given that dy dx is equal to x plus 1 over 2 minus y, where y not equal to 2. So the right hand side f of that is actually f of x comma y. So we first try to write this f of x in this form, g of x function of x into function of y, function of y. So that is the, suppose g of x we write into function of y. Here g of x is equal to, we can write it x plus 1, and h of y is equal to 1 over 2 minus y. So we write our differential equation in this form, g of x into h of y. So variable of separation technique is applicable here. Next thing is how to solve this differential equation. So we actually write in this form dy dx is equal to g of x into h of y. Once we write this differential equation in this form, dy dx is equal to g of x into h of y. Next, then we multiply dy by y terms, that is 2 minus y, 2 minus y, and multiply x term by dx. Next, integrate both sides. Integration is apply both sides. So that is 2 minus y integration 2 into y minus y integration y square by 2 is equal to x integration is x square by 2 and 1 integration is x plus some integration constant. So we got the solution, that is the our solution. So when we apply the variable separation technique, first thing is f of x comma y in this form g of x into h of x. Then we separate x and y terms, right hand side and left hand side. Then we integrate both sides. Then we get the our solution. Now I asked you one question. Can we always separate the variable directly? Answer is no. When the direct separation is not possible, we look for a suitable substitutions. Now that we have learned the method of separation of variables, let's move on to the another important technique for the solving the first order first degree differential equation, the method of the substitution. This method is useful when a differential equation cannot be solved by the separating the variable directly. Instead, we simply the equation by introducing suitable substitutions. Once a common case is when a differential equation can be written as a function of y by x. Suppose our differential equation we can write in this form, dy dx is equal to some function of x by y or some function of y by x. Then we apply a suitable substitution, that is y is equal to vx. Then we get a simpler differential equation. We usually solve these differential equations. Let's understand this method with an example. Suppose the example is dy dx is equal to x plus 2y x over x minus y. The first thing is we can write f of x comma y in this form, f of x comma y either function of x by y or function of y by x. So here if we common x numerator and denominator both, then we get x into 1 plus 2 over 2 into y by x, x taken common x, so that is 1 minus y over x. So this x and this x are cancelled, so that is 1 plus 2 y over x, that is 1 minus y by x. This function we can write is some function of y by x. So therefore our differential equations dy dx we can make it function of y by x. So here the method of substitution is applicable. So here we apply suitable substitution, that is y is equal to vx, where v is a function of x. This transform the given equation into a simpler form that can usually be solved using the method of separation of variable. So how can we solve? So that is, we got dy dx is equal to 1 plus 2 y over x by 1 minus y by x. That is 1 plus 2 y by x over 1 minus y by x. So we use the substitution, y is equal to vx. So now we find the derivative value dy dx. So differentiate the both sides. So that is dy dx is equal to, that is the multiplication formula. So first function is v into x derivative is 1 plus x into second term derivative, so dv dx. So now we substitute this value here. So this implies v plus x dv dx is equal to 1 plus 2v by 1 minus v. So we got this differential equation. Now we simplify and solve this differential equation. So we got v plus x dv dx is equal to 1 plus 2v over 1 minus v. So this implies x dv dx is equal to 1 plus 2v 1 minus v minus v. This v take right hand side, so that is minus v. So x dv dx is equal to 1 plus 2v minus v into 1 minus v over 1 minus v. So this implies x dv dx is equal to 1 plus 2v minus v plus v square over 1 minus v. So therefore x dv dx is equal to 1 plus v square over 1 minus v. So this implies 1 minus v over 1 plus v square is equal to dx over x into dv. So we separate v terms and x term. So here we use the method of separation of variable. So if we integrate both sides, 1 minus v dv 1 plus v square, and integration here dx over x plus some integration constant, then we get some v terms here and some x term plus integration constant, and we substitute v by y by x, then we get our solution in terms of y and x. So I think you understand the process of the method of substitutions. Write the differential equation dy dx is equal to f of x comma y in this form, some function of y by x or some function of x by y. If it is possible, then we apply substitution, y is equal to vx. Then we got a differential equation which will be solvable by the separation of variable. Then we got the solution in terms of x and y. Let's move to the another method. Can every first order differential equation be solved by the separation of variable or substitution? Answer is no. Some equation cannot be solved using this method when the equation can be written in the standard form. Suppose this equation dy dx plus p of x into y is equal to qx. This is the first order first degree differential equation. It cannot be solved by the separation of variable or substitution because we cannot write the right hand side. Therefore the right hand side is equal to qx minus px into y. We cannot write as a function of x into function of y, or some function of y by x, or some function of x by y. So we cannot write the right hand side in this form. So we cannot write the right hand side of the differential equation in those form. So we look the another method to solve this type of differential equation. Now let's move to the final method for the solving a first order first degree differential equation, the linear differential equation method. This type of equation we called it linear differential equation. This method is applicable when the given differential equation can be written in the standard form. This form is called standard form. Dy dx plus p of x into y is equal to q of x, where px and qx are function of x only or constant. Unlike the previous method we do not separate the variables or use a substitutions. Instead, we solve the equation by the finding an integrating factor. The call is the integrating factor. So the solution steps are: first find the integrating factor. Integrating factor is e to the power integration p of x dx. After finding the integrating factor, we multiply entire equation by it. So integrating factor is equal to e to the power integration px dx. So after finding the integrating factor, we multiply the entire differential equation by the integrating factor. So integrating factor into dy dx plus p of x y is equal to q of x into integrating factor. Integrating factor is e to the power p of x dx multiplied by dy plus p of x y dx is equal to q of x into integrating factor into dx. Therefore, this term we can easily write d of e to the power p of x dx into y is equal to q of x into integrating factor into dx. So this term we integrate easily, and here the all terms are involving x, so we easily integrate both sides. So integration we apply, that is d e to the power p dx into y into integration q of x integrating factor into dx plus some integration constant. Then we get the solution in terms of x and y if we integrate this term properly. So this is the steps are involving to solving the linear differential equation. First, a differential equation of the form this dy dx is plus p of y is equal to qx. P and q are the either constant or function of x. The step involved to solve the first order linear differential equation. First is write this differential equation of the form. This is the standard form. If we write the standard form, then we apply this method. First find the integrating factor, that is e to the power p dx, that is e to the power integration p dx. Then write the solution. In the solution of the differential equation is in this form: y into integration factor is equal to integration q terms into integrating factor into dx plus some integration constant. This is the final solution of this differential equation. Let's understand this method by solving an example step by step. Suppose the given differential equation is this: dy dx minus y is equal to e to the power x. That is the standard form of the linear differential equation. Here p of x is equal to minus 1 and q of x is equal to e to the power x. So first find the integrating factor is equal to e to the power integration p of x dx. Here p of x is equal to minus 1, so that is e to the power minus dx, so that is equal to e to the power minus 6. The second step is multiply the integrating factor the whole differential equations, so that is e to the power minus 6 multiplied by the whole differential equation dy dx minus y is equal to e to the power minus 6 into e to the power x. So this implies e to the power minus 6 dy minus y dx is equal to 1 into dx. Therefore this implies this term we can easily write d of e to the power minus 6 into y. So this is equal to dx. Now we integrate both sides, that is d of e to the power minus 6 into y is equal to integration dx plus some integrating constant. So this implies we get d and integration are cancelled, that is e to the power minus 6 into y is equal to x plus c. So this implies y is equal to e to the power x plus c. So this is the our solution of this given differential equation. So method is very simple. First find the integrating factor, that is e to the power integration p of x dx, and second we multiply integrating factor by whole differential equation. Then we can easily write the solution, that is y into integrating factor is equal to q into integrating factor into d of x plus some constant. This is our solution of the differential equations. Now that we have learned the basic concept and the different method of solving the first order first degree differential equation. Let's apply our knowledge to a real JEE Mains previous year question. This question was asked in January 2026 session of the JEE Mains. Before we start solving it, take a moment to identify the type of the differential equation and think about which method should be used. Once we have identified the correct method, solving the question becomes much easier. So let's solve it step by step. First, let's write down the given differential equation. So differential equation is this: sec of x dy dx minus 2y is equal to 2 plus 3 sine x, and x belongs to minus pi by 2 to pi by 2, and given that one condition y at 0 is equal to minus 7 by 4. Then asked what is the value of y at pi by 6. Which method should be used here? Separation of variable, substitution, or the integrating factor method? Think. Before we start solving the problem, always identify the type of the differential equation. Once we have identified it, from choosing the correct method become much easier. So look at this differential equation. So differential equation is similar to this type of differential equation: dy dx plus p of x into y is equal to qx. Manipulate this differential equation little bit, then we get this type of differential equation. So we simplify this differential equation: sec x dy dx minus 2y is equal to 2 plus 3 sin x. So this implies, then we divide this sec function: dy dx minus 2y sec of x is equal to 2 plus 3 sin x over sec of x. So this implies dy dx minus 2 cos x into y is equal to 2 plus 3 sin x into cos of x. Now we comparing our given differential equation with this linear differential equation, that type: dy dx plus p of x into y is equal to q of x. So comparing this differential equation with this differential equation, therefore we obtain px is equal to minus 2 cos of x and q of x is equal to 2 plus 3 sin x multiplied by cos x. So previously we studied this type of differential equation. So how to solve this type of differential equation? First find the integrating factor, then we write the equation of the solution in this form: y into integrating factor is equal to integration q into integrating factor into dx plus some integration constant. So first we find the integrating factor. So therefore integrating factor is equal to, the formula of the integrating factor is e to the power integration p x dx. So put the value here: px is equal to minus 2 cos of x dx. So this implies integration minus 2 sin x. Therefore we obtain the value of integrating factor is equal to e to the power minus 2 sin x. Therefore the solution, we know the solution is y into integrating factor. Integrating factor is this: e to the power minus 2 sin x is equal to q. Q is here 2 plus 3 sin x multiplied by cos x into integrating factor e to the power minus 2 sin x into dx plus some integration constant. Now we write our solution clearly: y e to the power minus 2 sin x is equal to, now we expand this bracket, then we obtain the two integrations. So therefore first integration is 2 cos x e to the power minus 2 sin x dx, and another one is 3 sin x cos x into e to the power minus 2 sin x dx plus integration constant. Now we denote these two integration First one is I1 and second one is I2. Therefore, I1 is equal to integration 2 cos x e to the power minus 2 sin x dx, and I2 is equal to integration 3 sin x cos x e to the power minus 2 sin x dx. The next job is to find the value of these two integration I1 and I2. First we find the value of I1, that is the integration 2 cos x e to the power minus 2 sin x dx. Now here we put 2 sin x is equal to z. So therefore 2 cos x dx is equal to dz. So therefore this integration becomes 2 cos x is equal to dz, and the put the value of 2 sin x is equal to minus z, that is, and dz. Therefore this integration is minus e to the power minus z. Now we substitute the value z by 2 sin x, so that is minus e to the power minus 2 sin x. Next we find the value of I2. So I2 is equal to 3 sin cos x e to the power minus 2 sin x dx. Previously we write it here. So therefore our target is to find this integration. Similarly, we put 2 sin x is equal to p. Differentiate it. 2 cos x dx is equal to dp. Next we substitute the value and obtain this integration in the form of p. So 3 is 3 and sin x is equal to p by 2. So sin x is p by 2, and cos x is equal to, from here we obtain cos of x d of x is equal to dp by 2. So cos x is equal to dp by 2 into e to the power minus p. Therefore 3 by 4 p e to the power minus p dp. Now we find the value of these integrations. Here we apply the integration Dippert's rule. So first function is p and second function is e to the power minus p. Therefore 3 over 4, first function is fixed, integration of the second, that is e to the power minus p, minus derivative of the first function, that is 1, integration of the second function into dp. So this is equal to 3 over 4 minus p e to the power minus p plus integration e to the power minus p dp. So this is equal to 3 over 4 minus p e to the power minus p remains same, and integration of minus p, that is minus e to the power minus p. So minus e to the power minus p is common, and 3 over 4 is remains same, so that is p plus 1. Now we substitute the value of p, that is minus 3 over 4 e to the power minus 2 sin x to sin x plus 1. So now we get the value of I2. So that is I2. Now we substitute the value I1 and I2 here. So therefore the solution is y e to the power minus 2 sin x is equal to I1 is equal to minus e to the power minus 2 sin x, and I2 is equal to minus 3 over 4 e to the power minus 2 sin x multiplied by 2 sin x plus 1 plus some constant c. This implies y is equal to minus 1 minus 3 over 4 2 sin x plus 1 plus c time e to the power sin x. So this is our solution. But the question asked what is the value of y at pi by 6. So our solution involved the constant c. So now we first find the value of c using this condition. Y at 0 is equal to minus 7 by 4. Given that y at 0 is equal to minus 7 by 4. So now we put our equation in this equation, that is star. We put y is equal to minus 7 by 4 and x is equal to 0. So that is minus 7 by 4 is equal to minus 1 minus 3 by 4 2.0 plus 1 plus c times e to the power 0. So this implies minus 7 by 4 is equal to minus 7 by 4 plus c. So this implies c is equal to 0. Therefore, the solution y is equal to, finally we obtain minus 1 minus 3 over 4 to sin x plus 1. Now we find our final value y at pi by 6. Now we put in this equation x is equal to pi by 6. So this implies minus 1 minus 3 by 4 2 into sin pi by 6 plus 1. So this is equal to minus 1 minus 3 over 4 2 into half plus 1, because sin pi by 6 is equal to half. So this implies minus 1 minus 3 by 2. So y at pi by 6 is equal to, we got minus 5 by 2. So finally we obtain our value y at pi by 6 is equal to minus pi by 2. If you look the option of this question, the second option is correct answer. If you have liked more JEE Mains previous year question, solution or video on any other mathematics topic, please let me know in the comment section. I will be happy to make those video for you.